Hey everyone, it's Nurse Sarah, and in this video, I'm going to walk you through how to solve injectable medication dosage calculations using dimensional analysis. Now, if you want to work these problems alongside me, you can download a free worksheet via the link in the description below. So let's get started. Our problem says that the healthcare provider has ordered 0.5 milligrams IM, so intramuscular, every month, and you're supplied with a vial that reads on it 1,000 micrograms per ml. So every ml that you're withdrawing from that vial has 1,000 micrograms in it. Well, we can already notice that what we're supplied with, that measurement of unit, versus what is ordered, they're completely different. We have micrograms here and then we have milligrams there. So we're gonna have to do some converting in order to get our answer, because this problem wants us to solve for milliliters per dose. So again, we're using dimensional analysis to solve these problems. However, maybe you prefer the ratio proportion method or the formula method or desired over half. If that's the case, you can access those videos up there to help you use those methods to solve these problems. So what I'm going to do first is I am going to first plug in what was ordered. So the healthcare provider ordered 0.5 milligrams, and that is one dose. The patient's actually getting it every month. Now, we're going to multiply that. And with dimensional analysis, you need to bring over your units because our whole goal is to cancel out certain units so we can get to milliliters per dose. So we're going to bring milligrams down here. Okay, well, we can't go and plug in our supplied part yet because it's in micrograms, so we have to do some converting. Therefore, we know that 1 milligram is equivalent to 1,000 micrograms. So we're going to write that right here. That cancels out our milligrams. Now, how did I know where to get that number? Well, that's from the metric table. So what you want to do is you definitely want to memorize this table, and as you solve these problems over time, it's literally going to become second nature, pulling those numbers so you can put them in your problem. Okay, now that we have that situated, let's set it up again and pull the micrograms over. And now we can plug in our information from our problem, our supplied part. So we know that our vial reads 1,000 micrograms is equivalent to 1 milliliter. That cancels out micrograms. We're left with milliliters per dose. That is where we need to get our answer. So we are ready to solve. So we're going to multiply everything at the top, then multiply everything at the bottom, then divide. So when we multiply everything at the top, what we're going to get is 500. When we multiply everything at the bottom, we're going to get 1,000. Now let's divide. 500 divided by 1,000, that is going to give me 0.5 milliliters per dose. And that is our answer. This problem says that the healthcare provider has ordered 1 gram IM every 8 hours, and you're supplied with a vial that reads 250 milligrams per ml. And what you need to solve for is milliliters per day. So always make sure you're looking at what you're trying to solve for, because this one's a little different. It's talking about the whole day, how many milliliters are you giving, not just per dose. So how I want to set this problem up with our dimensional analysis is first, I want to address this day thing. We've got to have that somewhere within our problem so we end up at the end with milliliters per day. So I'm going to go ahead and just address that. We know that there are 24 hours in one day. Boom, I have day in there. That makes me happy because now we're going to end up with that. Okay, so what we're going to do is we're going to bring hours over, and we know from our problem that every 8 hours the patient is getting 1 gram. That cancels out hours. Okay, so we're here with gram. We're going to bring that over. Okay, so what's ordered is in grams, and what we're supplied with is in milligrams. So we're going to have to do some pulling from the metric table because we have to do some converting. Okay, we know from the metric table that 1 gram is equivalent to 1,000 milligrams, and that cancels out grams. Okay, now that we have addressed that, we're ready to plug in with what we're supplied with, and we're getting closer to solving. So we're going to pull milligrams over. And we know from our problem that 250 milligrams is going to be in 1 milliliter. That canceled out milligrams, and we're left with milliliters per day. We're where we need to be. That's what we're trying to solve for. So now we're ready to solve. So let's multiply everything at the top, then multiply everything at the bottom, and then we're going to divide. So when we multiply everything at the top, we get 24,000. When we multiply everything at the bottom, we get 2,000. Now we're ready to divide. 24,000 divided by 2,000, that's going to give us 12. So 12 milliliters per day is what this patient's going to get. Now let's say you had to also give per dose. Well, what you could quickly do is just think about this. They're getting it every 8 hours. So we know there's 24 hours in a day. So if they're getting it every 8 hours, they're getting 3 doses, right? So what we can do is just say 12 divided by 3. That gives us 4. So it would be 4 milliliters per dose is what they would be getting every 8 hours, which would eventually lead to our 12 milliliters per day. For our next problem, I'm going to change things up just a little bit. We're still going to do an injectable medication problem, but I want to make it weight-based because you're going to see these type of problems on your dosage calculation exams. Our problem says the healthcare provider has ordered 2 milligrams per kilogram sub-Q every 12 hours. And what that's saying is that for every kilogram this patient weighs, they need 2 milligrams of this medication. Therefore, it's super important we know how much that patient weighs. We have an accurate weight, not an estimate. And it tells us that the patient's weight is 90 pounds. And we're supplied with 40 milligrams per 0.4 mLs. And what we're trying to determine is the milliliters per dose this patient is going to get. So we want to know what they're going to get at that every 12 hours. We don't care about the day. Therefore, what I want to do first is I want to go ahead and just address this weight-based part of it. So we're supplied with the patient's weight in pounds, but our medication is telling us kilograms. So we need to convert this pounds to kilograms. Therefore, then we can plug in what's ordered and then we can just solve. Okay, so first, let's start our problem with 90 pounds. That's how much our patient weighs, and we're solving for just 1 dose. Okay, we're going to bring over our pounds, and we need to convert because there's nothing in our problem that I can put here to start our dimensional analysis problem to continue it. So what I need to put here is from our metric table, and we know that 2.2 pounds is equivalent to 1 kilogram. Pounds cancels out, and now I'm in kilograms. So let's bring kilograms here, and now I can plug in my information from my problem. So it tells us that for every 1 kilogram the patient weighs, they need 2 milligrams. I'm going to cancel out kilograms, and I want to bring milligrams over. And this is where I can plug in what we're supplied with. So we're supplied with 40 milligrams. That's equivalent to 0.4 milliliters. This cancels out milligrams. Now, where am I at? I'm left with milliliters per dose. That's exactly where I want to be. So we're ready to solve. So we're going to multiply everything at the top, multiply everything at the bottom, and then we're going to divide. So when we multiply everything at the top, we get 72. When we multiply everything at the bottom, we're going to get 88. So now let's divide that. 72 divided by 88 gives me 0.818181, and it just keeps repeating. So now we need to do some rounding, and you always want to round according to your university's rounding rules. And what we're going to do to round is we're going to look at our number, and since it's less than 1 milliliter, we're going to round to the nearest hundredth. So what we're going to do is we are going to look at the hundredths place. Again, just to review, we have tenths, hundredths, thousandths. So we're rounding to the nearest hundredth. So to do that, we're going to look at the number next door, which is the thousandths place, and it's an 8. 5 or greater, that's going to require me to round this number up. So we're going to get 0.82 milliliters per dose. That is our answer. Now, just as a side note, let's say that this answer was greater than 1. We would round to the nearest tenth. So we would round to this point here. Okay, so that's our answer. Okay, so that wraps up this review. Now, if you want to work some more injectable medication dosage calculation problems, you can access a free quiz on my website via the link in the description below.